All right, so we've done that proof. Now we're doing this one. So on a side, if you have two complex numbers, z and w, oops, zoom in a little bit. You have two complex numbers, z and w, right? How do we find the midpoint, right? So what is the point that's the midpoint of the line that connects them? Well, really, if you were to look carefully at it, right, you can form two similar right triangles like this. Okay? And you will see that, okay? You will see that this is a complex number, right? This point over here is the midpoint when you go from Z to W horizontally. And this point is the midpoint when you go from Z to W vertically, right? And in general, right, I hope you can see it in one dimension. When you have in one dimension, right, let's pick some two numbers like, 3 and 12, 13 maybe, right? The point that's exactly halfway between them, maybe exactly halfway between them is going to be the average of 13 and 3, which is 8. So it's 3 plus 13, right, which is 8. Okay? So we're essentially applying the same principle twice, once horizontally, once vertically. So the midpoint is actually going to be the sum of the two numbers over 2, the average of the two complex numbers. Okay? So that's the idea. Okay? So we're going to repeat this idea a bunch of times, and that is all that we're going to do. And then the result is just going to sort of appear. Okay, so what do we want to do? We want to connect the midpoints of the opposite sides and prove that uh, this segment, these two segments bisect each other, which kind of looks true, but maybe in this case, but maybe not in general, but whatever, we want to prove it. So what I'm going to do is I'm going to use complex numbers to represent the vertices of this quadrilateral. And the midpoints, right? So what are the midpoints? Well, I'm going to use this here idea for each side. So this is a plus b over 2. This is b plus c over 2. This is c plus d over 2. And this is a plus d over 2. Remember, a, b, c, and d are not uh, names. They are complex numbers. So a, b, c, and d each has two coordinates, two like real and imaginary parts. Okay? So these are complex numbers. Okay. All right. So now let's take a look at the midpoints of the segment. So I'm going to take a look at the first segment, and I'm going to try to find its midpoint. So I'm going to use the exact same process again. So what is the midpoint of the first segment? Well, it's the average of its endpoints. So it's a plus b over 2 plus c plus d over 2. Those are its endpoints divided by 2, the average. What about the midpoint of the second segment? That's a plus d over 2 plus b plus c over 2 over 2, the average of its endpoints. Okay, we agree with that? Okay, so let's scroll away from the diagram for a moment. What is this equal to? Well, if I were to multiply numerator and denominator by 2, this is a plus b plus c plus d divided by 4. And this is also a plus b plus c plus d divided by 4. So this means that the midpoints of these two segments are actually the same point. Well, that's it. That means that they bisect each other because the point where they intersect is the midpoint of both of them, right? And actually, this point, actually, it's a special point. It has a name. It's called the centroid. When we talked about centroids of triangles, but this is actually a centroid of a quadrilateral. Okay, so because if you look at it, right, it's actually the average of the coordinates of its vertices. For a triangle, the centroid is the average of the three vertices. For a quadrilateral, is the average of the four vertices, and it actually applies to any polygon, 5, 6, 7, any number of sides. The centroid is the average of the coordinates of the vertices. All right.